So I'm going to go over some things to help us better understand. The first thing I want to talk about is points, lines, and planes. A lot of us are understanding this, and as you're saying it is, but I want to go over it one more time. Okay, so unlike the real world objects, there's these three different things that we call undefined terms, which are points, lines, and planes. Okay, they don't have any actual size. They're considered undefined terms because they are only explained using examples and descriptions. Okay, some of us we've already kind of seen already, especially in Algebra 1. You've seen this right here. A lot of you call this a graph. This is a graph with four quadrants, right? This graph right here is what we call a two-dimensional plane. It has a dimension of x and a dimension of y, and some might say it has length and width, right? So this is a plane that extends and keeps on going on forever, right? Inside the plane, you have several different pieces. You have a line. Now notice this line only extends in these directions, left and right. Doesn't really go up, down, right? It's just left to right, okay? And then inside the line is what we call a point. These are the three terms we're gonna be talking about: points, lines, and planes, okay? In a point, we have what we call an ordered pair. In a line, we have slope intercept form, and then a plane we have XYZ format. And we'll talk about that later on, but I don't want you to worry about these. They do have similar meanings, okay? There's exactly one through any two points. Means that there's only one, okay? One and only one. You can't have more. So when we have a line through 2 points, there's only one exact line, okay? So what we want to talk about here is a point is location is either shaped by like a dot, okay? It doesn't have size or shape, okay? It's by a dot, right? And this is what we call point A. It literally needs to be written like this, point A, okay? There's no really other way that you can write this. On a line, though, a line can be different. It can be written out three different ways, okay? And a line is made up of points. Doesn't have any thickness or width, okay? But exactly one line will go through any 2 points. That's the key piece right here. You have to have at least 2 points, and we're going to talk more about that later on. It's called a postulate. But when we have a line, we can name this several different ways, okay? We can name this as line M. It's usually like a little small letter that's not, it doesn't say that it's on that line. It's really saying that it's just a part of that line. That's what we're going to call it. Kind of like you could call someone their name, right? Like Jake, right? So that's Jake, right? Or and so here these would be two pieces. So let's say Jake had a middle name and a last name, right? Well, you can call Jake by that name as well, okay? Or you can call it different ways you can call your friend. Right now, I want to focus more back on the line and not about Jake. But right here, these are the different examples that we can call this same exact line. This same exact line has all of these different types of names. So first and foremost, we can call this line M because it has this little cursive M on the side, right? In script, lowercase. It's talking about this whole entire piece. We can call this the word. Notice we're using the word line PQ. Okay, we can use the word line PQ, or we can use PQ with what we have as a piece. It looks like a line right above it. This entails that this, in fact, is a line that goes forever in one direction and forever in an opposite direction. This is PQ. This means line PQ. Then you can also have the line QP. Now notice these two right here, line PQ, line QP, right? It doesn't matter which way you label the line, you can label it back and forth. Just like this one, line PQ, line QP, same direction, except instead of saying the word line, we have this piece. Now notice you have to have the arrowheads in order to indicate that it's a line. If you don't have the arrowheads, that means something completely different, okay? And on this line, we have to have at least 2 points. We can have 3, we can have 4, we can have 5, but we need to have at least 2 points. If we have 1 point, that does not determine a line. Okay, we need to have more than at least 2, at least. Okay, this plane is usually what we call the XY axis. You've known this, you've done this before, you've seen it a lot. A plane needs to have 3 non-collinear points, and non-collinear means not on the same line. These 3 points B, C, and D are not on the same line, because if I were to connect all 3 points, there'd be some sort of bend or curve. And we want to assume that all lines are straight, right? So this is a whole plane. You see this, it's like almost like a sheet of paper, right? If you think about it. So a plane can be named several different ways. There's a whole lot of different ways. Okay, you have another capital letter that's usually in the corners, right? And we can call this whole thing plane K, which is described right here. Then it depends how you want to number this or how you want to letter this. This plane will have several different names. Now, with this being said, all 3 letters need to be capitalized, and you need to use the word plane. If you just say BCD, that doesn't describe plane. You have to say plane BCD, right? I want to make sure that you understand this. Look at all these examples. None of these just have the 3 letters, so be careful with that, all right? Also, when you're explaining the letter K, make sure it's in lowercase, okay? Collinear, again, means that it lies on the same line. If collinear means the points are points that lie on the same line, then non-collinear means the points are not on the same line. Same thing with coplanar. Those are points that lie on the same plane. Non-coplanar are points that do not lie on the same plane. Okay? So I'm going to go here to this next couple of examples, talk about what we just said here in this discussion. Okay, right? So the intersection, right? So intersections of lines and planes. If we intersect 2 or more things, they usually have some common pieces. And in this case right here, I have line L and line M. And that's the way I would write this. Line L and M, they both intersect. When 2 lines intersect, they have exactly 1 point. And we're going to talk more about that again tomorrow. Here is 2 planes. 2 planes intersect. Now notice that right here you have 1 dimension. 1 dimension, 1 dimension, so you get 1 exact point, right? Here, these 2 planes are 2 dimensions, so that's why there's a whole line. It's not even a point, it's a whole line. So the intersection of 2 planes is a line. The intersection of 2 lines is a point. So it's almost like it goes backwards, right? In the 3-dimensional world, the intersection is a 2-dimensional. In a 2-dimensional world, it's a 1-dimensional, and so forth and so on, right? Okay, so right here we want to talk about a couple of things, and you're going to see some examples. Right here it says, use the figure to name each of the following. A line containing point X. So you notice here's options. Here's the X right here. Okay, we can call this line several different things. One of the lines I can use is line M. Okay, line M. Notice the lowercase letter m. It's not a point. It's determining the whole line. That's one way. I can also say line XR. Okay, we don't want to use this with over m because that would indicate that m is just 1 point. So don't ever use the arrowheads over m. You want to use it over 2 specific points that lie on the line. Another thing I can call this is line XY. Line XR. Notice how I'm using the arrowheads. They go both directions. Again, notice I'm not using M. Check this out. Now, this is one that you guys may not have seen. All right, line YR. There's no X there at all, but if you notice, X, Y, and R are all collinear. They're all on the same line. So all of these can be exactly the same. And then, of course, I could always say line XR. I could use the actual wording. Okay. Now, a line containing point Z. Right? Notice Z is right here. Well, guess what? Here in this situation, there's really only 2 ways to do this. You can use line L as the script of it, lowercase l. You can use RZ, right? You can use a ZR. You can even go backwards. Or you can use the actual word line RZ, right? If you feel like you want to use that. Okay, the next thing we want to talk about is a plane containing points W and R. So here's point W, here's point R. Okay, so far I know that plane B is 1 because that indicates this whole one because it has the points X and R. Now, W and R. Well, I can also call this plane WY R. Notice it's 3 capital letters. W, Y, and R are all on the same plane. I can call this WXR. right? Because X is still on the plane. These are three collinear points. They're not on the same line. Now, would I be able to call this plane XYR? Well, I wouldn't be able to call this plane XYR because this is a line. These 3 points are collinear, so I wouldn't be able to use that. So I want to make sure that we understand that. Okay? All right. So in these cases, a tightrope, right? We're naming these two different terms. Well, a tightrope, well, that should be easy. That's just a line, right? Something that you cross. A floor is a plane. So when you think about the floor, right, that's a plane. That's literally like the X and Y, right? If you think about it a lot, right? So number 6 says a line, draw and label a figure for each relationship. A line in a coordinate plane. I'm not going to really do these, so I'm going to go ahead and stop here. I want to go ahead and refer to this picture. Okay, this picture, because this is the one that a lot of people are getting wrong on the Wiser Me. Some issues here, and we'll talk more about that as the days progress in geometry. It says, how many planes are shown in the figure? There is a lot of planes. You have plane ACE, you have plane ABF, you have plane BFD, you have plane ACD, and you have plane CEF, right? You got, this is a three-dimensional figure. You'll notice you have what we call the base, and we'll learn about that. Then you have your two sides. Then you have the other two sides, the front and the back side, which you can kind of see. If you ever hold a prism, you'll notice, look at all the faces. Those are all of the planes. And then there's more types of planes that actually would cut through pieces, right? Because it's just that dimension. Okay, then it says name 3 points that are collinear. Well, I can name 3 points that are collinear. B, J, and F. That's probably the easiest one, or F, J, B, right? Those 3 points are collinear. Are the points A, H, J. So let's look at A, H, J, and D coplanar. Well, unfortunately, D doesn't lie on that same plane. A, H, and J line on this plane up on the side, kind of like the front view of the prism. D lies either on the back part of the prism, it lies on the floor part of the prism, or it lies on the side facing of the prism. It does not lie on the front part of the prism, if you think about it. All right, so hopefully that helps out. If you have any questions, please make sure that you come to tutoring after school, 4:30 to 5 p.m. every day. The after school tutoring link is in the resource folder inside Schoology for your geometry class. Have a good day.